Chapter 10, Energy Balance, Weight Control, and Eating Disorders, Screencast 1. This chapter is different from the other chapters that we have done so far in this course. It really is an application type chapter focusing on concepts related to obesity, eating disorders, etc. So it really is kind of an application overall of nutritional principles and how we see that expressed in our society. This first slide here is demonstrating obesity rates among adults in the United States in 2018. But I want to start off first. If we look at data from 1960 to 1962, approximately 45% were actually considered to be overweight or obese. 2009 to present, that has actually risen to 68%. Here we can basically see currently where a lot of the overweight and obesity is found. Typically in the South, unsurprisingly, is where we tend to find that. Now, one of the most important concepts in this course is balance, and now we're focusing on energy balance. And energy balance is defined as the relationship between the intake of energy and energy expenditure. If we look at energy equilibrium, that is the situation when calories consumed matches the calories or amount of energy expended. Positive energy balance is going to be the intake of energy exceeds energy expenditure, and this is a situation that will result in weight gain. A negative energy balance, that is a situation when energy intake is less than energy expenditure, and this is when we actually see weight loss. Now, examples of positive energy balance, and this is actually desired during growth stages such as pregnancy, infancy, adolescence, childhood. And this is important because what we see here, these are times of growth, and the energy is actually needed to support that. One thing to keep in mind here is aging does not cause weight gain. That's an important thing to keep in mind. Now, negative energy balance is desired in adults when body fatness exceeds healthy levels. Now, this is not recommended during growth stages as it can significantly have an impact on normal growth patterns. Here we basically look at examples of balance. The first scenario that we look at, we have an individual that's consuming 3,000 calories. They have an output of 3,000 calories, and there is not going to be any change in weight as they are in balance. Calories in is equal to the calories out. The middle scenario, we have 4,000 calories in, 2,000 calories out. We will see an increase in weight because this is a situation in which this person is in positive energy balance. Calories in is greater than calories out. The last individual, we have 2,000 calories in, but a very active person expending 3,000 calories. This will actually result in a weight loss because now we have a negative energy balance and calories in is less than calories out. Now, the amount of energy in food or beverages can be estimated using nutrient databases or software. Generally, the calorie values are derived directly by using a bomb calorimeter. Calorie content can also be calculated by determining the grams of the energy providing macronutrients and alcohol and multiplying these compounds by their physiological values. Now here, if we look at the example of the bomb calorimeter, we can see that there is an oxygen-filled chamber for food. We see that's surrounded by water. We also notice that there is a thermometer, and there's also a wire to ignite this. So basically what's happening here is you're actually measuring the energy produced by the combustion of the food item. So this would be an example of a direct measurement. Now, we now want to focus on energy expenditure. And the body uses energy for three main purposes. We have basal metabolism, physical activity, digestion, absorption, and processing of ingested nutrients, and there is a minor form of energy output that's known as thermogenesis. This is energy that is expended during movements such as fidgeting or shivering. Now here we basically look at balance, where intake is equal to output. And here we're basically looking at the energy yielding nutrients. We have protein, carbohydrate, and fat. Notice we also have alcohol because there is calories associated with that. Here we actually see the output side. And notice the largest component is basal metabolic rate. We see a thermic effect of food, physical activity, and thermogenesis. Now, basal metabolism, or BMR, this is the minimum amount of energy expended in a fasting state to keep a resting, awake body alive in a warm, quiet environment. Approximately 60 to 70% of our total energy expenditure is based on the basal metabolic rate. The processes that are involved include beating of the heart, respiration of lungs, and activity of other organs. Now, resting metabolism is used if a person is not fasting or rested. Now, basal metabolic rate and resting metabolic rate, they are expressed as the number of calories burned per unit of time. Typically, with women, it's approximately 0.9 kcals per kilogram per hour, and men, it's slightly greater at 1.0 kcals per kilogram per hour. Notice body weight here is expressed in kilograms. Now, factors that actually increase basal metabolism, the biggest factor is going to be muscle mass. Muscle mass is metabolic tissue. It's expending calories. So that is going to be something that increases metabolic rate. We have a larger body surface, male gender, body temperature, higher than normal secretions of thyroid hormones, growth stages, nervous system activity, drugs such as caffeine and tobacco, and also recent exercise. These are all things that will have an impact by increasing basal metabolism. Factors that decrease basal metabolism would be a lower than normal secretion of thyroid hormones. Remember, they're responsible for metabolism, a restricted caloric intake, less body surface area and muscle mass, and then, unfortunately, our basal metabolism will start to decrease after the age of 30. Now, the biggest chunk that we actually have control over is going to be the energy expended for physical activity. Physical activity can increase energy expenditure above basal metabolism anywhere from 25 to 40%. Now, being active or inactive really is determining much of our total energy expenditure. So it is important to try to increase the amount of activity that we participate in on a regular day. Examples would be climbing stairs instead of taking an elevator, standing on a bus rather than sitting, walking, or riding a bike rather than driving. Now, one of the biggest reasons we see such a large rate of obesity in North America is partly caused by the inactivity of most individuals. Now, another factor that we have to take is the thermic effect of food. Now, it takes energy to digest, absorb, transport, store, and metabolize the food that we consume. This actually accounts for 5 to 10% of our total energy consumed. It's influenced by food composition, the thermic effect of food for protein-rich meals is 20 to 30%. The thermic effect for food for carbohydrate-rich meals is 5 to 10%. The thermic effect of food for a meal high in fat is 0 to 5%. And alcohol is about 20%. Now, the other thing that will have an impact on the thermic effect of food is the size of the meal. Larger meals obviously will have a higher thermic effect. Now, there's something also known as adaptive thermogenesis, and this involves heat production. Now, and heat that's lost to the environment. Now, this is not a large contribution to total energy expenditure, and this is actually produced when body expends energy for non-voluntary physical activity. An example would be shivering that is triggered by extreme cold, overfeeding an individual, trauma, starvation. So these activities are fidgeting, once again, shivering, the maintenance of muscle tone, and holding the body upright. So those are things that will be expending energy, but not to a great degree. Now, there is something known as brown adipose tissue, and this is actually a very specialized form of fat tissue, and it participates especially in thermogenesis. This is fat tissue that actually contains lots of capillaries and mitochondria, and we expect to find brown adipose tissue in small infants and also animals that hibernate.